These are your 5-4 video notes on complex numbers, and we're continuing on with quadratic concepts. We've done a lot with quadratic so far. We've talked about the different forms of the equation, graphing, converting, completion of the square as a method to convert from one form to the other, quadratic formula for solving, also factoring along the way, and we're going to continue on with the idea of solving today. But before we can do that, which is kind of the last thing we'll hit in this set of notes, is talk about what a complex number is and what an imaginary number is. So for starters, we're going to do some basic solving, which we have done already in the past, and just talking about your normal algebra 1 solving. So if I just subtract 1 to both sides, I get x squared equals -1, and then pull in my square root because I want to take the square root of both sides to get rid of my squared. And then we stop here for a second, and in the past we would have said, well, this is not possible. You can't take the square root of a -1. Remember that when you do take the square root while you're solving, plus and minus has to come into your problem, but still we go, well, that's not actually possible. Put in your calculator, you're not going to get an answer. But it is possible if we introduce a new number system, which is imaginary numbers. And so we're going to handle this issue when it pops up by saying that we can call that a special type of number, which is an imaginary number, or the imaginary unit. Square root of -1 is now going to become I for us. So really the answer to this equation when we solve it is plus and minus I. Now we'll get a little more into the detail of I in a second. But for starters, let's just talk about simplifying roots where we've got negative under the root. And some of this stuff fairly simple, like these numbers, but how do we deal with the negative? So this is not something you need to do on paper, but at least in your head for a second, think about it as I would split my root up into 2, which is a totally legitimate thing to do. So square root of 16 times square root of -1, and that square root of -1 is I. Now when you guys see this problem, you don't need to do what's in blue, but just think to yourself, okay, I really have an imaginary number going on because of this. So then I would say, well, that's 4 times I, and then 4I. Probably once you get good at this, you'll just go from seeing this right to an answer. But for starters, it's good to think about it as this, so you understand where it is the I comes from, which is the square root of -1. And doing the same thing here, split it up. So I've got 7 times I, 7I. Square root of 8, so we're doing the square root of 8. There's another thing too that we'd like to think about is simplifying the root. We did this a little bit talking about it when we were doing the quadratic formula, but remember that that's really root 4 times root 2, so now just focusing on this part, and that's square root of 4 is 2, so that's 2 root 2. Square root of -1 is your I, so 2 root 2I. And then, for example, 17 doesn't have it's not a perfect square. We can't split it like we did here, so then we just got to go with it and have the square root of 17I. So there is how we deal with the square root of a negative as it comes up in our just kind of general work with numbers. And when you do, you just think about attaching I to the answer. And otherwise, you can work with your root as normal. Okay. Let's get into the powers of I. So powers of I just help you understand a little bit more about when the exponent I is bigger than 1, what you do, and there's some ways to simplify that. And anything the first power itself, so we're going to start with that, and then we're going to keep this in mind as we start working through the other powers and just show you how it works. So this concepts here are called the powers of I. So I squared would be I times I, if you just think about the rules of exponents. But we know that I is the square root of -1, so that's root 1, negative square root of 1 times negative square root of 1, which is -1. So it turns out that I squared is actually -1. Now, if you keep this kind of logic going, if you go I to the third, that'd be I squared times I. And I squared is -1, so that's actually one to kind of memorize. It's good to know because it pops up other places. I squared is -1. Well, -1 times I is -I. And then, again, I'm just using the rules of exponents here. So if I do a squared and a first, that's a third, so I can do that. Here, for example, fourth would be squared and squared, but that's -1. So is that. So -1 times -1 is 1. The list you kind of got to get to know is I to the first, I to the fourth. So I to the first, of course, is itself. I squared -1. I to the third, I to the fourth is 1. And then after that, the pattern just continues. So there really is no reason to memorize or know more than the first 4 powers because it just duplicates itself. So I can keep doing this stuff, and I could show you all that, but actually it's just a repeat of the pattern. The row that you kind of want to focus in on is this last row where you've got multiples of 4, so like 8, 12, 16, 20, and so on. Because that'll help you simplify these largers where what you don't want to do is you don't want to sit here and run this list out. Keep running the list over and over and over again, try to find these. You want a way to break this up easily so you can get there quickly. And what you do is you want to get your exponent, whatever it is as close you can to a multiple of 4, and then whatever's left. And what I'm going to do by doing that is I'm going to split this up. So I'm going to take the 10th like I did these, and I'm going to break it into 2 pieces. And so I can say 10 is for sure 8 and 2, because the rule of exponents here is when I multiply the same base, I add the exponent. The reason I go for 8 is it's the closest multiple of 4, which puts me in this row, to 8 as I can get without going over, and then whatever is left. And then I can just kind of go to my list and fill in the blanks. So remember, anything that's in the multiple of 4 row, so 4, 8, 12, 16, 20, those will all be 1s. So I got a 1. We know that I squared is -1, then multiply them together. Once you get that little trick down, then it's just a matter of how close can you get. So 17, well, I'm going to go 16 because 16 is in the 4 row, right there. And it's close I can get without going over. So 16 and 1 is a total of 17. So I to the 16th would be 1 and then times I, and you get I. 23, I'm going to go as close as I can to 23 without going over. So if I'm following this pattern, that would be 20. So I'll have 20 and 3. And again, anything that's 8, 16, 20, anything that's a multiple of 4 is an automatic 1. So I can put a 1 in there. And then I to the third is -I, and I have to know that. So you do have to have memorized this first row, first, second, third, and fourth. After that, you should be sitting pretty good. And that doesn't really make a difference how large the exponent gets. If it's 400, it's 4 million, it's whatever. Go to the closest multiple of 4 that you can without going over. So that would be 401. And 400 is in this row if you go way out because it is a multiple of 4. So that's 1 times I, and you get I. So these are just practicing with the powers of I, and it's a real simple. Once you get the idea of get yourself as close as you can to the original exponent that's a multiple of 4 without going over, and then what's left has to be I to the first, I to the second, or I to the third. And again, I do have to know at least this list. All right, let's show you some other things we can do with complex numbers. So you notice I use the word complex number. We're going to get into some operational stuff, which is add, subtract, multiply. And a complex number is a combination of a real number with an imaginary number. So we have a standard form for that, which is a plus bi, where a represents the real part, and bi, because there's your I, is your imaginary part. And they're fairly easy to work with. Most of what we're going to do, you'll find to be the same kind of algebra you would do with any other type of number, turns out. So let's go ahead and get started. So basic operations with complex numbers. So adding, subtracting, right? It's a like term concept. I color-coded to help you guys make sure you're clear on what goes with what. But basically, you put the real numbers together and the imaginary numbers together. So I would treat that as a like terms idea. So when I go to kind of reorganize a little bit, my red is my real, my blue is my imaginary. Pretty simple, straightforward stuff, and then just combine them. A being your real part, bi being your imaginary part. Nothing hard about that. Subtraction, you know the idea is here I got to, of course, distribute the negative in, so make sure you do that, distribute the negative into the second set, but I'm still going to put the reals together, so real with real, imaginary with imaginary, and then combine my like terms. So addition with complex numbers is super simple, just like doing any kind of algebra combination with like terms. Multiplication, so we got kind of two things going on here. We'll do a little bit of distributing, so take the I, distribute it in. Now here's where powers of I are going to come back into play a little bit. So I multiply that I in, so 3i, 2i squared, so I times I. Just treat like another variable, like an x, right? X times x, x squared, same thing, I times I squared. But anytime I squared shows up in your work, you want to immediately replace it with -1. And then we're going to do a little bit of reorganization here, because this is now becoming my real number. So again, we're going for a plus bi format, so -2 plus 3i. Again, pretty simple. It's just that when this pops up, you just have to keep reminding yourself I squared shows up, or any power bigger than 1, actually do some replacement. So here I'm going to do a FOIL. I also have the box method over there because I thought, I haven't talked to you guys a lot about box in videos, but I know it pops up in the homework once in a while. And your pick, FOIL, box, it's all going to produce the same result. So I've got the terms laid out here. I've got them laid out here. The box, remember, is like basically you do each number times each number on each side. So 6 times 2, 6 times 3i, 2i times 2, and 2i times -3i. But if you like FOIL, of course, that produces all the same stuff. You notice I squared popping up. So again, as soon as I squared shows up in your work, you immediately replace it with a -1. That causes this to become +6. And then again, I'm going to go like terms. So I've got, so again, combining my terms, right? I got 12 and +6, 18. And then I've got -18, +4, -14, a plus bi. So doing addition, subtraction, multiplication, right? It's really no different than you do with any other kind of variable, except how we deal with I squared. That, of course, is different because we replace it with -1. Okay, a few things to show you here, and then we're going to wrap it up here pretty quick. So solving. So solving is your typical kind of stuff, right? Like that one I showed you kind of at the very beginning of the notes. So what I'm going to do here is just do my algebra, subtract 9, which is going to give me my square root in a second. So x squared equals -9. Put my square root in, square root both sides, because that would get rid of the square. That's opposite operation. And then here now I'm doing this without doing like the little split thing I showed you earlier, which you really don't need to do. Just realize that when you see the square root of a negative, that's going to produce an I, and the square root of 9 is 3, plus and minus. And then remember, when you're taking the square root in the process of solving, plus and minus. So that problem, pretty straightforward. Now, for a 3-term like this, of course, is a question we always ask ourselves, is does it factor? And what I did here is just showed you some possibilities with 8 being 8 and 1, that's a factor of 8, and then 4 and 2 being factors of 8. And I checked the inside outside and see if I can get that middle term. And this would give me a 1 and 8, so there's no combination of 8 and a 1 that would produce 4, so that's out. Here's 2 and 4, and if I do my outside inside, I got 4x and 2x. There's no combination I can put those two together and produce that. So it's a no, and that means quadratic formula. So again, we're kind of reviewing a little bit of the earlier sections, so now I'm going to go ahead and get the quadratic formula set up. Remember, I'm going to take my numbers A, B, and C from here. So this is A, this is B, this is C. So I'll drop those in, and then start simplifying the problem. So I've got negative, negative, positive, that's 16. Remember when you square a negative, it's negative times negative, so that's positive. Sometimes we make a mistake and put negative 16, but it's positive 16. And this number is negative, so when I go to do 16 minus 32, here comes the imaginary part of our answer. You're going to get the square root of a negative number. So I get the square root of a negative. Now, again, as a reminder, what I'm going to do here is treat this like I did earlier in the notes, and I'm going to change that out with a 4 and change it out with an I, so this is really going to be a 4i here. You don't need to do this work on paper, but just showing you again where it comes from. And then, so that becomes my plus and minus 4i, and then 4 and 4 can both be divided by 2, so I can take it all the way down to 2 plus 2i and 2 minus 2i. So there are two solutions, quadratic, right? But they're complex numbers. Okay, so you can apply solving the way we always do algebra, or it won't factor, so we use the quadratic equation, quadratic formula, and the only thing you got to watch out for is, again, how you deal with I when it pops up in the problem. Okay, and the very last little bit of this is kind of working the problem in reverse. So we're going to give you a set of zeros, which are like saying solutions, and work backwards. So what we're going to do is start by undoing this, and we're trying to come up with the general form that has these two solutions or has these two zeros. So we'll start working our way backwards a little bit. So I'm going to subtract the 2 back over and add the 4 back over, which creates kind of like a factor. And then what I'm going to do is actually put those together as factors. So these zeros produce these factors, and then of course we're going to FOIL it out and get our final answer. Again, you can go box method on that if you wanted to. I didn't do it here. I'll do it again in a minute. But first, outside, inside, last, still a pretty easy way to go. Combine your middle terms. And there is going from zeros to a general form. And this idea of lead coefficient 1, that's because your x times x, these are both 1. So you get a positive 1x squared. So your lead coefficients are 1 out here. Okay, let's do it with plus and minus 2i. So I'll do plus and minus 2i. So I'm going to move the 2i back over by subtraction and then by addition. That creates kind of like a mini equation. Put those two together as factors, do my FOIL, or my box method, whichever one I like. And the middle terms drop in this case because plus and minus 2i are going to cancel each other out, or plus and minus 2xi I should say, are going to cancel each other out, and all you're left with is just x squared plus 4. Now I would say that, if you think about it for a second, here's another way to come up with the idea of x squared plus 4. These two zeros would have to come from you solving this equation. So if I was doing it like I was showing you earlier, like subtract 4, take the square root, doing this kind of stuff. If it just occurs to you that, hey, where would these two zeros have to come from? They'd have to come from taking the square root of a negative 4. You might just come up with this just by thinking about this instead of doing this work, but of course this work is totally fine. Okay, that's going to do it for your 5.4 notes.